We are looking here at the trapezoidal rule and for examples of how to do the trapezoidal rule. With -2 to 10 as my limits in a table, well, luckily I'm using the entire table, so I'm going to have 6 different, well, not rectangles now, but trapezoids that we're going to be finding. And here's the formula for trapezoidal rule: 1/2 base 1 plus base 2 times height. So I'm going to need to have 6 of those. 1/2 base 1 times base 2 times the height. 1/2 base 1 base 2 times the height. 1/2 base 1 base 2 times the height. And you'll keep on going until we have 6 of them. Okay? Now, the height in this is just like when we were doing before with rectangles. It was length times width. Really, it was the width of the interval. That's what your height represents. This is like your y values. The height is your x values. So as you're going through from -2 to 0, the width, the height, is 2. From 0 to 1, it's 1. From 1 to 5, it's 4. And continuing through, 5 to 6 is 1. 6 to 9 is 3. 9 to 10 is 1. Now, for these guys, base 1 and base 2, well, 0 is the left end point, 4 is the right end point. You're literally adding those two up. For the second rectangle, from 4 to 5, so you're adding 4 and 5. Excuse me. For the next one, you're adding 5 and 3. You're just adding the left and right endpoints together. And then you're going to add them all up, and you're going to get a final answer of 55 when you do that. Now, the other way to look at this, instead of thinking like a trapezoid, 1/2 base 1 times base 2, we said base 1 and base 2 are the left and right endpoints. Well, if I add them up and cut it in half, that's just taking the average. So you're just taking the average of the endpoints times the height. So if you want to think of it that way, you can almost think it back in terms of a length and a width every time. So there's still going to be 6 of them in the end, because we have 6 different regions going on here. So the width is still the same the way we're doing it here: 2, 1, 4, and then 1, 3, and 1. For my average though, 0 and 4, what's the average of 0 and 4? It'd be 2. The average, what's in between 4 and 5, would be 4.5, 4.5. Between 5 and 3 would be 4. Between 3 and 9 would be 6. Between 9 and 4 would be 6.5. And between 4 and 6 would be 5. And guess what? 0 plus 4 divided by 2 is still 2. 4 plus 5 divided by 2 is 4.5. You're going to add them up, and you're going to get the same thing either way. So either one of those strategies will work to get you the same exact value. Now for 21, you need to make your own table for this one. So I like making mine sideways when I can. Doesn't matter if you go up, down, or left, right. You're going from 1 to 3, and they want 4 subintervals. So the width of the whole thing is 2, divided by your 4 subintervals means you're going to be counting by 1/2. So 1, 3/2, 2, 2.5, which is 5/2, and 3. You're going to plug those in to a calculator, and you'll get some y values. You're plugging it into this equation, x cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Those are the easy ones. These guys, 3/2, when you square it, well, you could go, or cube it, I mean, you could just make it 27 over 8, and you can make this one 125 over 8. If you turn them into decimals, this guy would become 3.375, and this guy here would become 15.625. So again, what you're going to do is you're going to take essentially a length and a width each time for each of the 4 intervals that you have. Your width each time is going to be 1/2, because we're doing equal intervals from 1 to 3. That's where we came up with right at the beginning. As for your length, 2 ways to do it. You can either add them up, so 1 plus your 27 over 8 and divide it by 2, or you can just do the average separately and put the number in. So really what you're doing is taking 1/2 of each add up. So 27 over 8 plus 8. This would be 8 plus 125 over 8, half of that. And this would be 1/2 of 125 over 8 plus 27. When you add all of those up, the numbers you should get like 1.09375. You should get 2.84375. You would get, for the third one, 5.90625. And the last one is 10.65625. If they were fractions, just so you can see those numbers, if you did it with fractions, that's actually how I did it first. I had 35 over 32. I got 91 over 32. I got 189 over 32. And I get 341 over 32. So fraction-wise, it's 656 over 32 when you add all those together. When you do it with a decimal, it comes out as 20.5, and that's what this guy will reduce to. This fraction will reduce to 41 halves. 41 divided by 2, because you can divide the top and bottom by 16. Okay? Again, worried more about the setup, whether you're using the average idea or just the basic trapezoid formula. Either way will work if you use your trapezoidal rule.